Okay, so there's some things I left about what it's going to take for you to grasp and understand quantum field theory or quantum mechanics and stuff. Quantum mechanics is, I guess, the not the yeah, it's kind of the end game of physics, honestly. Um, Luckily, regular physics is way easier to do because you just need an intuition for things that are macroscopic and stuff, and um, or you just understand some the basic terms and stuff. Um, Thankfully, most of us have taken physics in high school, middle school, you know, maybe college too and stuff. A lot of us still remember a lot of physics. Um, but yeah, so you want to you want to keep the earlier stuff in mind and you don't forget it, no matter how you view yourself. You persist until your resistance to the subject breaks and stuff. And then you persist some more until you're a master of the subject with peer-reviewed, solid academic sourcing, grounded logic, facts, etc. to back up what you are saying. You make it clear that you know the topics and what you are talking about. You use respectful language and don't try to leave any reader wondering anything by leaving as much to be plainly understood as possible. You show you have done the hard work, so physics does not remain some lifeless pile of records, unthought ideas, etc. Now, one of the greatest crimes of intellect is to leave knowledge muted and stuff. You just let it sit there. It's not telling anyone anything. It's not being used by any system and stuff. And it's just kept there with no plan, you know, no problems being solved, no great new creations being made, nothing being improved, maintained, repaired, you know. That's a crime of intellect. You've basically wasted all of that time and energy thinking and have carried out nothing with it and stuff. Which arguably is how I've lived like half of my life, right? Um, I can say 4 whole years of my life have been spent doing absolutely nothing. Okay. Um, or just doing counterproductive things, honestly. Which is like almost like the epitome of being stupid, right? Like instead of like, doing things that are like generally generative and stuff, you're doing things that are just damaging and that are just, creating damage. Um, I'll safely admit that I've made some very unproductive decisions in my life. Anyway, so now now there's about 72 subjects out there and stuff. We can we can learn and as much as as much as we want from there and stuff. Question, assess, discuss. Make creations, or um, solve problems, whatever. We can even discover new subjects if we want to. It's entirely new, non-overlapping subjects. So this is unlikely, honestly. Um, but there's some subjects that we never, ever, ever touch for extremely good reasons. We not only don't need them, but they're too dangerous. Okay. I refer to them as crackpot subjects, but they go by many names. Okay. Um, why do I call them crackpot subjects again? Because these subjects are so ultra sensitive, so high risk, potentially so dangerous that you have or just so nonsensical that you have to be an absolute crackpot to be interested in them. Like if you learn this stuff, you have lost your mind, guaranteed. Like you've already met the definition of somebody who's out of their mind. So let me just laying that out there and stuff. Hmm. So some examples of that described respectfully and stuff in respect to the sensitivity that's going on here. Highly sensitive information, meaning information that can be easily be abused by conduct disordered or just very stupid people and stuff. There's people that will take any that will take certain information and absolutely raise hell with it and stuff. Um, there's information protected by operational security protocols. Operational security is a very important part in U.S. policy and stuff, law, bylaw, whatever you want to call it and stuff. You must know it and stuff. If you work for or with an organization, they have operational security protocols, and you got to make sure that you are respecting them. Okay. Um, that includes personally identifying information and sensitive personally identifying information. Okay. And there's also subjects and certain types of capabilities, okay? Things that horrify, potentially destroy, or corrupt any innocent or good person. Some subjects are so foul, so infernally bad, they can easily make an otherwise good person out-of-hand villain from just one page. Because the stuff contained in those pages is just absolutely bonkers and destructive, harmful stuff. Stuff that can't really be controlled by human beings or any system they've made. Okay, nonsensical literature with no factual backing or groundability, which also poisons the mind with bad influence and stuff. There's plenty of books out there that tell you how to be that tell you how to like do some pretty horrible things to innocent people, um, to just good people that just don't deserve it. Okay, people that really aren't asking for it. Um, or political, commercial, purely truth claiming or religious gibberish. Okay, lies. Yeah, there's plenty of stuff that just isn't true in some literature or stuff that's just not sourced well. Overprudence, only because this leads to stupor-like psychological modes, since humans are fundamentally reactive. Books that basically tell you that try to stress the rules to the point where you're not doing anything at all. That's or doing much less, that's a problem. Okay. You know, now what else do you need to have in you to study quantum field theory? Going back to quantum field theory specifically. You need to be able to pay attention to the right details and stuff. You're in the realm of science, math, physics, and stuff. Those terms need to be understood and respected those fields. Okay. Being in the right attitude and perspective. There you go. I just segued to the second bullet point, understanding things respective to the field that you're reading, an appreciation for fact, logic, and reasoning, a willingness to let facts work for you and stuff. Okay. A lot of people are very used to sports, combat sports, or even esports and stuff where you're giving a lie to every detail, and your brain can be trained on that to the point where you don't learn anything and stuff. You have to stay out of that state of mind, okay? Need a clear mind, need a dogged passion for learning and stuff. I don't care what you're capable of, be hungry to learn. You'll still make out 10, 20 times better than if you didn't try, okay? Letting the information and facts fill your mind and speak for themselves. When you try to impose your reactions or opinions, you stop learning, you block things out. I'm just re-emphasizing what I talked about, trying to give the lie to every detail and stuff. In competitive sports, even like speed chess and stuff, you're giving the lie to everything, exploiting the flaw in every plan and stuff. Almost everything your opponent does, like, okay, this is my new plan, this is what I'm going to do. But you're basically going, no, the hell you're not, because this is a losing idea and stuff. With every move, your opponent is more or less saying, like, okay, this is giving me the game, this is saving me and stuff, and now I'm going to win. And you're saying, hell no and stuff. That mindset goes away when it comes to things like quantum field theory, theoretical physics, this type stuff. You should not have any gaps in your understanding and stuff. The matter of reference needs to be understood completely. Things will unpredictably stop short, spread thin, become obfuscated, but your mind needs to be relentless in trying to clarify all of it. It needs to constantly come up with ideas to fill in the blanks. With that, you need extreme calm too. Your mind needs to be peaceful, calm. You need to understand that every kind of thought has its own timing that it occurs and stuff. Your fast thoughts will limit you to the magnitude depth of the slower thoughts. The slower thoughts limit you to the practicality, the efficacy and stuff of the faster thoughts. For starters, okay, there's just some thoughts that naturally take longer than others because the human brain needs to go through a process and stuff and needs to see something's there first, needs to react and stuff, and needs to process it and stuff and kind of go through that hierarchy of thinking and stuff until you get down to critical, deep critical thinking, potentially even creativity and stuff. And you need to create memory permanence and stuff. There's a whole process you need to go through. But once you get used to this process and stuff, your brain gets trained on it. You get memory permanence and everything. And yeah. Now, once you understand the ideas, test them out with practice problems. Often practice problems hint at new important things to learn, but what matters is that your work has coherent progressions. Unclear, scattered expressions or non sequiturs are a show of poor understanding. Now, if you have a professor or instructor and stuff, your professor or instructor might not appreciate the language you use and stuff, your mode of interaction or whatever. And that's a separate problem you'll have to solve. So theoretical physics can be an arduous undertaking. But you also got to understand that when you're taking exams, quizzes and stuff, you're going to have a certain amount of points for answer. You got to know the instructions and expectations of the course, and you have to make your points logically and coherently to show that you made those points and stuff. You don't necessarily have to write out the nitty-gritty of everything, but you have to show that you understand the important things to logical completion, to where you formed a coherent path to the conclusion. Shows why your calculations are correct. Okay. Now I also talked about how quantum field theory is basically the future, and we're still kind of in the beginning of the amazing things it can do and stuff. I talked about some applications in part 1. What are the applications in part 2? Like what are some more applications? There are tons. Okay. There's no limit to what quantum theory can accomplish and stuff. Okay. What are some possible things that can be made with it? Teleporters, hard light, force fields, and stuff. A lot of this comes from sci-fi and science fantasy and stuff, but it's possible with quantum theory because of how fundamental a lot of the particles are, and because of how just the extremely malleable nature of massive energy and stuff. Massive energy can be ultimately made to do anything. Okay. Munitions, lasers, and stuff, and which we've technically already achieved, right? But we can make better ones. Transmutation, quantum supercomputers, 476 megapixel capable graphics cards. Transmutation, intergalactic communication. Materials made from standard model particles and stuff, as in, for example, a bullion made from stabilized bosons and stuff. Imagine seeing that in person and with the properties it might have and stuff. It almost blows away the conception of chemistry, but it's theoretically possible. You might have to mix the bosons with something or have it in a certain container, but theoretically you could do it. Time-stopping devices and stuff. Levitation device, invisibility technology, indestructible materials. Okay. And the applications for medicine, unbelievable. All kinds of amazing machines, prosthetics, even new kinds of medicines that potentially completely reverse conditions with their quantum behavior. Lightsabers, yeah, lightsabers. Okay, world expansion, planning, and creation technologies. If a planet is, if we keep running into planets that we cannot build things on and stuff. We can have technology for creating planets, for expanding the surface area of the Earth. You know, um, in case human population continues to grow out of control. Environmental conservation technologies. You know, smart surveillance systems and other law enforcement surveillance systems. Kardashev scales 0 through 7 technologies. Artificial wormholes and white holes. Black hole dissipators. Black holes can be a huge problem. They can be a really huge problem when it comes to spacefaring. You know, devices for collecting all kinds of information and stuff. You know, basically answering the risk of very precious items and artifacts being destroyed. But these require interdisciplinary knowledge. A lot of this you won't learn from the direct study of physics. You will need to know other subjects too. But yeah, this is just some of the stuff that's possible with quantum theory, which is why it's so important for people to learn this and stuff. Quantum theory is not meant to just be some silent library of books, some files on a computer and stuff, or you know, or just somebody armchairing it in their office or at home. It's meant to. It is information of some of the highest quality. Okay.